Now we come towards certain applications of the orbital velocity. A satellite is revolving in a circular orbit at a distance of 2620 kilometers. So we can convert kilometers into meters, or otherwise the whole data must be in kilometers. But normally find that the data is in MCAS system, so kilometer must be converted into meters. That will be more convenient. Now, what we have to do, calculate the orbital velocity and the period of revolution. If we know the orbital velocity, we can calculate the time period. Radius of Earth is known to us, 6380 kilometers. Mass of Earth is given, that is 6 into 10 to the power 24 kg. And gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kilogram power minus 2. So we have to find the orbital velocity and the period of revolution. The orbital velocity will be taken as, that is, gmm over r square is equal to mv square over r. Cancel off the numbers and make the subject of equation as velocity. So in the solution it is indicated that radius of Earth is re plus h. That is, h is included because the body is at a height of 6380. So radius added to height will be nearly 9,000 kilometers. That is 9 into 10 to the power 6 meters. Mass of Earth is known to us and gravitational constant is also known. So orbital velocity of the satellite at a specific height can be calculated by the following formula. So the formula is gme over re plus h under root. We computed the values of g, then me, then re, then h, and after all calculations and taking the square root, the value comes to be 6.67 kilometers per second. Now, if you wanted to find the period of revolution, it should be 2 pi r over v. Now, here r will be re plus h and v will be, that is, orbital velocity. So, we compute the values of pi, re and h and divide by the orbital velocity, which is found to be 6.4 10 to the power 3 meters per second. And after the calculations, we find that it will become 8474 seconds or 2.35 hours. So if seconds are divided by 3600, we will get hours. Now in another example, a satellite is revolving in an orbit close to the Earth's surface. It was just touching the circumference. Taking the radius of Earth as 6400 kilometers, that is 6.4 10 to the power 6 meters. We have to find the value of orbital speed and the period of revolution of the satellite. So we have to find orbital speed and period of revolution. The formulas we have discussed earlier, those formulas are to be computed and then we will substitute the values, we will necessary calculations and we will come to the conclusions regarding the orbital speed and the period of revolution. So as shown in the calculations, orbital speed is under root g into re. I have explained earlier. Put up the value of g and r and you will get orbital velocity. Now orbital velocity is known. We have multiplied by that is 10 to the power 3 meters per second. So it will become 7.92 kilometers per second. Now we come towards the period of revolution, that is distance over speed. Distance is 2 pi re divided by v naught. Compute the values and get the value of t. It is found to be 84.6 minutes. Now in another example, an artificial satellite. Now we are again using the term artificial. It means the man-made satellite. So artificial satellite revolving coplanar with the equator around the Earth appears stationary to an observer on the Earth. Calculate the height of the satellite above the Earth. So when we say that Earth as well as observer both appears to be stationary, it means that the spin velocity of the Earth and the body will be the same and their period of revolutions are same. So now let us see the solution to the question. that is h is the height of the satellite above the Earth. The period of revolution is 2 pi r over v. So we put the value of 2 pi r, that is 2 pi into re plus h power 3 by 2 divided by re multiplied root g. If the period of revolution of satellite be equal to the actual rotation of 24 hours of the Earth, that is, satellite is revolving from west to earth, west to east, then satellite will appear stationary relative to Earth. And in that case, if we find the time period, time period is 24 hours multiplied by 3600 seconds. So we will make the calculations, and the final calculations will be Re plus H power 3. All other values are put, and we made this particular equation. So now again the numbers are totally put up, and we are feeling that there is no, that is our concept is that Re plus H whole cube. So we put the value of Re, then we put the value of H. All these values are computed and we made the necessary calculations. These calculations can be made with the help of logarithm table also, or directly by division and multiplication. We can solve this question. So it will be 75.3 into 10 to the power 21 meter cube. But at the same time, a more significant method of writing is divide the number by 10 and multiply by 10. So it will become exactly 7.53 into 10 to the power 22 meter cube. Now, Re plus H is known to us, and we will put the values. And after putting the values, our net result of the height will come as 35,800 kilometers. So, if a satellite is based at about 35,800 kilometers from the circumference, that is nearly 3,600 kilometers, then the point at this height above the Earth's circumference is called the parking orbit, or it is called the parking orbit or geostationary orbit. So it is about 36,000 kilometers from the circumference, and if in that value we add 6,400 kilometers, then that will be the height from the center of the Earth.